Welcome students, we are starting our study on Calculus 1. Now what is the meaning of the word calculus? It is imperative that we understand the essence of the subject by knowing its meaning. Now two of the ancient languages define calculus to be as rock, and the other language defines calculus to be a pebble. Of course both the things means it's a hard stone. Now we know that in those days, long time ago, rocks were used to create fire, and fire was everything. So without fire you wouldn't be able to cook your food, and more so you wouldn't be able to keep yourself warm. If there is no warmth in the room or in the tent, it's impossible to fall asleep, because the central nervous system wouldn't let the body to go into a state of hibernation, or in other words, it is just not possible to rest the body when the environmental conditions are not suitable. So having mentioned this, you have to know that when I talk about rocks are very important for everything. Without rocks, in fact, you wouldn't even have the ability for the earth to retain water. So that is how they defined calculus to be. Now from here you can understand the importance of this great subject, calculus. So having mentioned this, it is important for us to know the branches of calculus. There are actually three branches in calculus. The first one is called as limits, the second one is called as differentiation, and the third one is called as integration. Now we would start off with limits and then move on to studying differentiation and then to integration. Now before I could start off with the limits, let me just explain to you what is limits. Now we are always dealing with functions, have that in mind. Everything that you see even today in the real life can be associated to a function, or a function can be defined. So that is the reason we are so much so interested in learning about a function. The function can be anything. It can be your car, it can be your savings in the bank, it can be your health, it can be the food that you are buying every day, or the food or the provisions you are buying from the supermarket. Anything and everything can be related or associated or created to be a function. So having mentioned this, whenever we talk about limits, we are more so interested in learning about the function when x is going towards a certain value called as a, and the value that the function will hit is called as L. This is often referred to as the limit of the function. Now why is it so much so important for us to understand the limits? Now for example, you got a washing machine. Let us just take this scenario. You got a washing machine and you are feeding in clothes, right? Now this washing machine is actually a function, f of w, let me assume it. Now you are simply feeding in clothes after clothes. Say for example, you have fed in 3 trousers and 2 sports jackets, and then your blanket, hat, say 5 hats, you want to wash your hats, say sports hats, and what else, and maybe around 7 jeans. You have actually fed your washing machine with all of this, and then you are switching it on. Now what would happen to the washing machine? Do you think you would be able to successfully wash all this and take it out and then reuse the washing machine tomorrow? Of course not. It wouldn't be. In fact, maybe within the first 10 minutes your washing machine will just break down, or will be burned out, or in fact the circuit in the washing machine would also damage the refrigerator that is present next to the washing machine, because the connectivity is all interconnected. So the idea what I'm trying to place here is, there is a limit to the loads that your washing machine can take. You cannot go beyond that limit. Simple as that. That is exactly what we are looking for. We wanted to know the limit of every function that we are coming across. So why would we want to know? If you would have known the limits of your washing machine, you would have protected the washing machine. So that would subsequently enable you to save money. and that would have prevented you from borrowing, and that in turn would have prevented you from going bankrupt, because you were borrowed and suddenly you were laid off and you were not able to repay the, say, $1,000 loan that you have taken from the bank, and the interest for the $1,000 has been 15%, and it had accumulated, and finally you would have it had actually pushed you to a limit that you are not able to pay your rent for 3 months, and thereby eviction notice has been issued, and now you are homeless. It's finished. All because you do not know the limit of a function, because you do not know the limit of the washing machine. So limits are very, very important concept. So having mentioned this, we are focusing on this. Now, how am I going to represent this by means of a sentence? So I would state it like this: the limit of f of x as x approaches a is L. So in case of the washing machine, as time approaches 10 minutes, the washing machine breaks down. Simple as that. But in this case, as x approaches a, the limit of f of x is L. So that is the introductory definition I wish to provide for limits. Now, having mentioned this, for the limit of a function to exist, it should have the left hand limit and the right hand limit, and the left hand limit should be equal to right hand limit. So this is a very important requirement. Now I'm going to explain to you what exactly the meaning of left hand limit and what exactly is the meaning of right hand limit. Now we start off with left hand limit. Let me write that down. Left hand limit. Now imagine this is the x-axis. I'm just placing the x-axis, and there is a point called as A here. Now x is actually approaching this point. X, when I say x, x means some variable. It is going towards this point A from the left hand side. This is called as the left hand side, right? Now as x is going towards this point A, the function will also be moving. We do not know how the function is moving, but the function will be moving. Now as the function is moving, there will be a point where the function will hit the y-axis, and that point will be the value for the function when x is moving towards A from the left hand side, right? So we represent that as limit x tending to A from the left hand side, and we obtain some value and state it as P. This is the way we represent this. Now let me explain to you what is called as right hand limit. Now we got the x-axis and we got the point A. Now x is approaching A from the right hand side. This is called the right hand side. Now as x is approaching A from the right hand side, the function will also be obtaining some values, and at some point the function is going to hit the y-axis, and that point will be the limit of f of x as x is approaching A from the right hand side. When we are writing, we will write it like this: x is approaching A from the right hand side, and the function is taking some value, say q. Now the function has got a p when x is approaching towards a from the left hand side, and the function has got a value q when x is approaching a from the right hand side. Now if limit x tending to a negative of f of x is equal to limit x tending to a positive of f of x, then we say f of x has a limit. In other words, we say limit of the function as x approaches a exists. Okay, so this is how we state it. And what is the requirement? The requirement should be the left hand limit should be equal to the right hand limit. Now the best way to understand any concept is example, and so we will embark on doing examples and understanding this concept more better. Okay students, in this lesson we will understand the concept of neighborhood and limiting value. Now imagine you are given f of x is equal to x squared over x, and you are asked to study this function. Study this function as x is tending towards 0. Now you have to know there is a difference when you say x is tending towards 0 versus x is equal to 0. Now when you say x is equal to 0, it means x takes the value 0 exactly. In other words, there is no up or down, so there isn't anything called as less than 0 or more than 0. X exactly takes the value 0. Now when x takes the value 0, you cannot cancel the terms of x. So that means when x is equal to 0, let me write that down here. When x is equal to 0, f of x is undefined because you get 0 over 0. So you can't say anything about the function, and the function is undefined. But on the other end, when x is approaching 0, so you have, this is the x-axis, and you got 0 here, and you have a variable x that is approaching 0. It can approach 0 either from the right hand side, or x can approach 0 from the left hand side. Now when that happens, the meaning is, let me just take case 1. Case 1, x is going towards, or in other words approaching 0 from the left hand side. So that means I can always take a value which is closer to 0. Say for example, if I'm taking a value of x as 0.00 with a negative sign, right? So on the side it's going to be negative. So if I'm going to take a value which is 0.001, I'm going to take this value. Now what happens when I take this value 0.001? I would get f of x. So f of x is going to be equal to negative 0.0001 raised to the power of 2 divided by negative 0.0001, and definitely there is going to be a value here. So definitely what we can do is we can cancel one of the quantities here, and that would give us a negative 0.0001. So the point I wish to tell you is we are able to cancel these because of the fact that x is not equal to 0. So x is taking a value that is closer to 0. Now if I were to be observing the value of f of x, this is very much close to 0. Negative 0.00 and a 0.1 is actually close to 0. Now if I were to take even closer value, say if I were to take x to be as say negative 0.000001, this is even more close to 0. So when we talk about the left hand limit, we are actually talking about a limiting value. So have that in mind. Limiting value. That means the value will stop at this particular point. It will just hit a roadblock at this point 0. So 0 will be the roadblock. It doesn't matter whether you're taking x is equal to 0.00001 or 0.000001. The roadblock is 0. Okay, now why am I trying to show you all this? Because if I were to draw the graph for x and versus f of x, definitely for every value that I'm taking for x approaching 0 from the left hand side, I would definitely have a graph flowing down. That's what I'm trying to tell you. Now at x is equal to 0, the function ceases to exist. The function is undefined. So at this particular point there is going to be a big hole. The function is not defined here. On the other end, when x is approaching 0 from the right hand side, the function will again start to grow. It's going to be a straight line. The function will be growing. It's going to be a straight line. Again, for different values of x, we are going to have a subsequent value of f of x. So I hope you are able to catch the point. At x is equal to 0, the function is undefined, but when x is approaching 0 from the left hand side and from the right hand side, the function has a value, and we can clearly say f of x has a limit, or in other words, limit x's. I can also state it like this: limit x's for f of x as x approaches 0 from the left hand side and x approaches 0 from the right hand side. And in either of these cases, limit x tending to 0 minus of f of x is equal to limit x tending to 0 plus of f of x, and that value is going to be 0. That roadblock is going to be 0, because we are actually choosing a value which is so close to 0, and in all cases we will be able to approximate it to be a limiting value. So that is the concept you will have to understand. So we have studied some important concepts here with regard to the neighborhood. So when I say neighborhood, I am actually choosing the closest value to 0. So I took a value, say the best value should have been this, because this is the neighborhood of 0, right? So whenever we talk about neighborhood, we're talking about that value which is very close to the value under consideration. In this case it is going to be 0, either on both the sides, whether it's be the left side or on the right side. The roadblock or the limiting value that we are focusing on is going to be 0. Now since it is approaching 0, we are free to cancel this. So if I were to write this, f of x is equal to x when x is approaching 0, and it is undefined when x is equal to 0. So this is the best way to represent the function. So I hope you got the gist of this topic, neighborhood and limiting value and the meaning of x equal to 0. So we will move on to the next concept. Students, we are expected to evaluate limit x tending to 0 of x squared over x. This is just the extension for the previous question. Now, what do you think? Can we cancel these x's present here? Of course, we can cancel this because of the fact since x is tending towards 0, and that is the reason we are able to cancel this. So that would mean that x is not equal to 0 here. X is not equal to 0. So x and x can be cancelled. So I get limit x tending to 0 of x. Applying limits, APL stands for applying limits. We get the answer to be as 0. Now it is imperative to understand that 0 is the limit for this function. Why? Because even if x were to approach 0 from the left side, and x approaches 0 from the right side, limit x tending to 0 from the left side of the function is same as limit x tending to 0 plus. In both the cases, the limiting value is 0. So this would mean limit, I can state limit of f of x, x's. So this is just for your information. Since the limit for this function x we are in a position to say that the limit of f of x, I'm going to use a space here, limit of f of x is 0. You can just state that. If you want, you can state that. Or the best way to state it is limit x tending to 0 of f of x is equal to 0. This is the best way to state.
Students, now that we have understood the definition of limits, there are a few laws which is required whenever we are handling questions related to limits. Now, so the laws are as stated as follows. So, foremost, we need to start off like this. Suppose that limit x tending to a of f of x and limit x tending to a of g of x, they exist and are finite numbers. Okay, then the following laws hold good. So the first one is the sum law, that is limit x tending to a of f of x positive g of x is equal to limit x tending to a of f of x positive limit x tending to a of g of x. Limit of the sum is equal to sum of the limits. Now this sum can be replaced with the difference operator in this fashion. Law number 2. This is what is called as a scalar property available in limit. Suppose c is a constant, then limit x tending to a of c times f of x, this is a square parenthesis, so you can put it as square or curl, is equal to c times limit x tending to a of f of x. The meaning is, if you have a constant within the function or product multiplied with the function, you don't have to apply the limits for that constant. So just take the constant out and just apply limits for the function. Now number 3, limit x tending to a of f of x times g of x is equal to limit x tending to a of f of x times limit x tending to a of g of x. So what is the meaning of this? Limit of the product is equal to product of the limits. So this is a very important law. Limit x tending to a of f of x divided by g of x, you got something like this. This is equal to limit x tending to a of f of x divided by limit x tending to a of g of x. Limit of the quotient is equal to quotient of the limits. So these four laws are very important and have to be used whenever we are dealing with limits. Moving on, law number 5. Suppose you get something of this fashion, limit x tending to a of f of x. Now this is raised to the power of n. Then this is equal to limit x tending to a of f of x. This entire thing has to be raised to the power of n. So this is a very important law and it will come in handy. Next, if you are asked to apply limit to a constant, then you will get back the same constant. So you can't apply limits to a constant. So have that in mind. Law number 7, let me use the space here. Suppose you are asked to apply limits for this function, say x to the power of n. Then straightforward, you need to just place the limit and write the solution as a power n. Law number 8, if you got something like this, a function of this fashion, x raised to the power of 1 over n. So usually they will give it like this, nth root of x. Now this is actually limit x tending to a of x raised to the power of 1 over n. If you were to apply the limits, then this is going to be a raised to the power of 1 over n. So moving on, law number 9 is a little bit interesting. Say you have limit x tending to a of nth root of a function. To apply the limits, this is equivalent to nth root of limit x tending to a of f of x. So have this in mind. Moving on, finally, just to round it up, say question, in other words, law number 10. Suppose you have limit x tending to a of x, then straightforward, you need to apply the limits. So the solution is going to be a. So we have got 10 of these laws and we will be using these 10 laws. So let's start with an example. Now we are given this question, limit x tending to 2 of 3x squared negative 2x positive 5. So foremost what we have to do is we will have to apply the limits law. So I'm going to use limit of the sum is equal to sum of the limits. So it's going to be limit x tending. So let me state the law. So before we could start off, I'm going to say we know that limit x tending to a of f of x positive g of x is equal to limit x tending to a of f of x followed by the positive sign and limit x tending to a of g of x. Limit of the sum is equal to sum of the limits. So I'm going to rewrite this as limit x tending to 2 of 3x squared negative limit x tending to 2 of 2x positive limit x tending to 2 of 5. Next we know that the scalar property of limit x tending to a of c times say g of x is equal to c times limit x tending to a of g of x. So by this property, this is equal to 3 times limit x tending to 2 of x squared negative 2 times limit x tending to 2 of x positive limit x tending to 2 of 5. So now APL stands for applying limits we get. So if you have to apply limits, this is going to be 3 of x tending to 2 raised to the power of 2. So negative 2 times of 2. For a constant, the constant is retained. So this is 3 times of 2 squared is 4. Negative 2 times 2 is 4 positive 5. So this is equal to 3 times 4 is 12. Negative 4 added with positive 5 will give me positive 1. So this is 12 added with 1, which is going to be 13. So therefore limit x tending to 2 of 3x squared negative 2x positive 5 is equal to 13. So this is the solution we get. Friends, now we will see a few examples of solving limits using the technique of factorization. Now this is a very powerful technique. Now suppose you have a question, say limit extending to 1 of x squared negative 1 divided by x negative 1. Now if you were to apply the limits, you are going to get 1 negative 1 divided by 1 negative 1. This is 0 by 0 form. Now we will study in detail how to handle 0 divided by 0 form using other techniques. But in this scenario, we have a 0 over 0 form, which means the limit is undefined. The conclusion in this case is limit is not defined. That's the best word to use, not defined. So if you were to apply the limits straightforward, then limit is not defined. This is what you are going to get. Now we have to somehow maneuver ourselves out of this 0 by 0 form. Now it is imperative to understand, once you get 0 divided by 0 form, it means limit is existing, but we will have to capture that limit. So that is basically the indirect understanding. So let's do that. I'm going to use factorization. So what I would do is I would rewrite x squared negative 1 as x negative 1 times x positive 1, and that's divided by x negative 1. So this is going to be limit x tending to 1. So x negative 1 gets cancelled. You are left with limit x tending to 1 of x positive 1. Now if I were to apply limits, this is going to be 1 positive 1 is equal to 2. So now I've got the limit. So this is a beautiful question to show how factorization comes in handy in obtaining the limit for a function. So we will move on to other questions. Now let me use this particular space and show you one more question on factorization. Say you are expected to solve, say, limit x tending to 5 of x squared negative 25 divided by x negative 5. So straightforward application of limits will give you 25 negative 25 divided by 5 negative 5, which is 0 over 0 form. So as I mentioned to you, clearly they will come to a conclusion that the limit is not defined or the limit doesn't exist. But we can find out the limit using factorization. So I'm going to rewrite x squared negative 25 as x negative 5 times x positive 5 divided by x negative 5. So x negative 5 gets cancelled, giving me limit x tending to 5 of x positive 5. Now applying limits, this is going to give me 5 positive 5, which is equal to 10. So that is the solution for this question. So we will move on to the next one. So given this question, we are expected to find the limit. So foremost, if you were to apply limits, then you would get 4 positive 0 raised to the power of 2 negative 16 divided by 0, which is 4 squared negative 16 divided by 0. You're getting 0 over 0 form. Now the general conclusion would be limit is not defined or limit doesn't exist, and so on and so forth. But actually we can use the technique of factorization in extracting the limits for this function. So that is exactly what I'm going to do. So what I would do is I will expand this. So this is going to be 4 squared positive 8 times x positive x squared negative 16. Negative 16 positive 16 can be cancelled, giving me 8 times x positive x squared divided by x. Now I can take x out. That will give me 8 positive x divided by x. X and x can be cancelled. So now I get limit x tending to 0 of 8 positive x. So if I were to apply limits, so this is going to be 8 positive of 0, which is equal to 8, and that is the solution of the question. So we will move on to the next question. So question number 4. Limit x tending to 0 of 5x to the power of 3 positive 8x squared divided by 3x to the power of 4 negative 16x squared. Now if you were to be applying limits, clearly you will get 0 over 0 form. So we need to avoid that. So for that I would be taking x squared out that would give me 5 times x positive 8, and from here I would take x squared out, that would give me 3 times x squared negative 16. So x squared can be cancelled. So now I have a 5x positive 8 divided by 3x squared negative 16. Now if I were to apply limits, of course 5x and 3x squared gets cancelled, giving me 8 over 16 with a negative sign, which is nothing but 1 over 2 with a negative sign. So that is the solution. So all of these questions are involving the technique of factorization. We will do one more such question and then probably we will move on. So we will start off by applying the limits. Now if I were to apply limits, this is going to give me 4 negative 2 positive 1 negative 3 divided by 1 negative 1. 4 added with 1 will give me 5. Already there's a 5 there, so this is going to be 5 negative 5 divided by 1 negative 1, which is 0 divided by 0 form. So we need to get out of this form, and that is possible only by factorization. Now what I wish to do is I would like to apply the concept of synthetic division in finding out the root. So I will just place 4 here, the coefficient of all the powers of x along with the constant term. So 4 followed by negative 2 and 1 and negative 3. Now if I were to place 1 here, I bring 4 down, so 1 multiplied with 4 will give me 4. I need to add these two terms, that will give me a positive 2, and then 1 multiplied with 2 will give me 2, 2 added with 1 will give me 3, 3 multiplied with 1 will give me positive 3, 3 added with negative 3 will give me 0. So this is what I've got. So this is called the quotient. Now my quotient is, I started with degree 3, so this is going to be degree 2 followed by 2x positive 3. So this is what we have got. So if you want to write the given quantity 4x to the power of 3 negative 2x squared positive x negative 3 as a product of two polynomials, then that would be x negative 1 times 4x squared plus 2x positive 3. Now why did I place x negative 1? Now x is equal to 1 is a root, so x negative 1 should be a factor. Now if you were to multiply these two things, you will get back. So let me just show that to you. X into 4x squared will give me 4x cubed. X into 2x will give me 2x squared, and then along with that, so let me just show that to you. So x, I'm going to multiply each and every term with x, so it's going to be x to the power of 3 followed by 2x squared followed by 3x. Now multiplying by negative 1, you get negative 4x squared negative 2x negative 3. Now 4x cubed is unchallenged, so just place it. Now 2x squared with negative 4x squared will give me negative 2x squared. 3x with negative 2x will give me positive x negative 3. So that is what we have got, right? This is the original thing, 4x cubed negative 2x squared positive x negative 3. So this is what we have as the original problem. So now what I'm going to do is I'm going to write x tending to 1 in place of the numerator. I'm going to write it as a product of terms as x negative 1 times 4 times x squared positive 2x positive 3. This is the way I'm going to write, divided by x negative 1. X negative 1 gets cancelled, giving me limit x tending to 1 of 4x squared 2x positive 3. Now I apply the limits, so this is going to be 4 times of 1 raised to the power of 2 positive 2 times of 1 positive 3. This is 4 positive 2 positive 3, 4 plus 2 6, 6 positive 3 gives me 9. So this is the limit for this particular function. So having done all these questions using the technique of factorization, we move on to the next topic. Students, we are given this question. The question says the graph of f of x is given as shown here, and then we are expected to find the value of function at x is equal to 1, and then from there onwards we are expected to state if the function is defined at x is equal to 1, and subsequently the third question is to find if the limit for f of x exists. Of course we are focusing on the point x is equal to 1. So step number 1 at x is equal to 1, so let me just write here as the answer.
Now at x is equal to 1, what happens? F of x is equal to what? At x is equal to 1, clearly you can state, or you can see that the function takes the value 2. So at x is equal to 1, f of x is equal to 2. Probably I can just state it like this: f of 1 is equal to 2. So I can write that. Now since the value exists for f of 1, so this would mean f of x is defined at x is equal to 1, because at x is equal to 1 we are able to get a value for the function. Okay, now the next question is to determine the limit of f of x. Let me write that down. To determine the limit of f of x at x is equal to 1. So how are we going to determine? We will have to determine when x is going towards 1 from the left hand side, and we will have to check if that is equal to x tending to 1 from the right hand side. If these two are one and the same, then this would mean f of x has a limit, right? So that is the conclusion. So let us just take a value of x closer to 1. As x approaches 1 from the right side, x is going towards 1 from the right side, very close. I'm just taking a value which is very close to 1 on the right hand side. Now if I were to take a value which is very close to 1 on the right hand side, subsequent f of x is going to be very close to 0. So that means we can suitably conclude, as x is tending towards 1 from the right side, f of x is going towards 0. So I can write that hence limit x tending to 1 with the index being positive sign, f of x is equal to 0. I can state that. On the other end, as x is approaching 1 from the left hand side, now let's check if x is approaching. For x is going towards 1 from the left hand side, if I'm going where to take a value which is very close, which is very close to 1, not 1 but very close to 1, this would link me to a value 3. So I can write that as x approaches 1 from the left hand side, f of x is moving towards 3. Hence I can state that limit x tending to 1 from the left hand side, f of x is equal to 3. So if I were to take this as 1 and 2, from 1 and 2 we see that the left hand limit is not equal to right hand limit. So this means f of x doesn't have a limit. Have a limit as x approaches 1. So that's the best way, and we can write it mathematically. X tending to 1, f of x is equal to limit does not exist. So that's a conclusion. Though the function is defined at x is equal to 1, the function is defined at x is equal to 1, but the limit for the function doesn't exist. So that ends the question. Students, we will move on to the next one. To wrap this question up, students, we will do one more problem connected with this graph. Let us consider, or I would say, if you are being given this question, to find f of x at x is equal to 6. So let this be question A. And question B, they are asking us to check if f of x has limit at x is equal to 6. So these two questions are being given. So let us handle those two questions. Now at x is equal to 6, this is the point. What is the functional value? So the functional value is this black dot. So f of x in this case is equal to 1. So that is the solution for question number A. Now to find if the limit exists for f of x at x is equal to a, we will have to find out what happens when x approaches 6 from the right hand side and what happens when x approaches 6 from the left hand side. Now let me do that. Now take a point which is very close to 6 from the right hand side. So if I were to do that, find the corresponding functional value. The functional value that corresponds to x which approaches 6 from the right side would be somewhere over here. Now that corresponds to the y-axis, and that would be, so let me write that down. That value is given to be as 2. So as I mentioned to you, when x is approaching a given value, the function also approaches a value, and that value is obtained at the intersection of the y-axis. So that is exactly what I am doing here. So when x is approaching 6 from the right side, the function is approaching 2. Now subsequently, let us find what happens when x is approaching 6 from the left hand side. So we need to choose a value that is very close to 6 from the left side or from the left hand side. So in that case, this would correspond to a value onto this particular point, which in turn can be traced back to the same value 2. So in this case, f of x is also equal to 2. So 2, when I'm writing 2 because that's a limiting value. So how do we represent this? So question number B, I'm writing the solution over here. We observe that as x approaches 6 from the right hand side, f of x is approaching the value 2. Also, as x approaches 6 from the left hand side, f of x is approaching the value 2. So this would mean limit x tending to 6 of f of x is equal to the value 2, because you don't have to write this, just for your understanding, because limit x tending to 6 from the right side of f of x is equal to 2, which in turn is nothing but x tending to 6 from the left hand side. So this is the reason that we are able to arrive at this particular conclusion. So if you were to be asked in short, that's the limit for this function x is at x is equal to 6, your answer should be yes, it does. So you move on to the next question. Now next we will move on to the concept of one-sided limit. Now let me define this. Now at the end points of an interval of domain, only one-sided limit is defined. So let me just give you this illustration. Now let us take, for example, f of x is defined. I'm just giving you here. F of x is defined for every x element of a comma b. Now this is a closed interval, right? Now if you are actually trying to find the limit, you cannot apply left hand limit. Limit extending to a minus of f of x will not exist. Okay? Why? For the simple fact that f of x is only defined for the closed interval. So having mentioned that, if you are interested, or in other words, if you have to find the limit, then limit x tending to a of f of x will be limit x tending to a, that is x approaching a from the right hand side. This is what will be existing, and that should be finite. If it is finite, then the limit for the function exists. Simple as that. So have this in mind. And having mentioned this, so this is for at x is equal to a. So this is case 1. Now let us talk about case 2. Now case 2, at x is equal to b. Now what limit will exist? Now if you are trying to find limit x tending to b from the right hand side, then that is not going to happen here, because the function f of x is defined only for the closed interval. So naturally the only possibility in this case as x is tending to b will be limit x tending to b from the left hand side, and that would have to be finite. If it is finite, then the limit for the function is existing, because you have to understand one thing: limit existing for the function in the interval is totally different from the function being defined. The function can be defined, but there is no guarantee that the limit of a function does exist. So those two are different concepts, and it is important that you understand. So let's move on to the next topic, students. Students, let us do a few examples to understand the one-sided limit. Now suppose you are expected to find the limit of root of x when x is approaching 0. What would you do? Would you find the left hand limit and the right hand limit? Well, for that we need to go to the graph. So this is x-axis, this is y-axis. The root function would be of this fashion, something similar to this. Now clearly you can see that the function is only defined along the positive side of the x-axis, so from 0 onwards. So there is no need for you to actually obtain the left hand limit, because we are expected to find the limiting value for this function as x approaches 0. So naturally you might be thinking we should also calculate x approaching 0 from the left side, but there is no need for this because the function is not defined here. The function is only defined from 0. So this is not required. So what is required? It is enough that we find what happens to the function as x approaches 0 from the right hand side. This is what is required. So as x is approaching 0 from the right hand side, the closer it goes, clearly you can see that the function will also be approaching the point 0, and hence the result is 0. Maybe you can state it as x tends to 0 from the right hand side, the function f of x is equal to root of x, maybe you can write it, tends to 0. So that is the solution for question 1. This is not needed, this is actually for your understanding. The solution stops here the moment you place 0. So that is the solution for this first question. We will go on to the next example. Question number 2, you are expected to find the limit of the function ln of x as x approaches 0. So the best way to solve this question is to draw the graph. This is approximately the graph of ln x, and this point is 0. So this is the y-axis is moving off, and there is an asymptote here. Now what are we required to find? Are we required to find x tending to 0 from the left side? Is the function defined here? No, this is not required because the function is not defined on the left side. We are only expected to find what happens to the function as x approaches 0 from the right hand side. So this is what is needed. So let us go and calculate this. Now if I were to move towards 0 from the right hand side, now clearly you can see the function. This is function f of x is equal to ln x. This is moving towards the y-axis. Will it touch the y-axis? No. It wouldn't touch the y-axis, but it is moving close. And where would it end? Nobody knows. And what do you have here? You got negative infinity on this side. So what's the outcome? The outcome is going to be negative infinity. So what is your conclusion? Limit does not exist. Okay, so you can simply say LDE. So that's the solution for this question, students, and probably we can draw the line for the value. So we'll move on to the next one. Now, question number 3, we are expected to find the limit of cos inverse of x as x approaches negative 1. So this is a beautiful question. So if you were to draw the axis, it is imperative to understand that x value is between negative 1 and positive 1. So let me place negative 1 here and positive 1 here. Now the graph when cos inverse of x, right? We are talking about cos inverse of x. When x is equal to 0, the hit will be pi over 2 here. This is pi over 2 and this is pi. So if you were to draw the graph would be something, it will be moving here and then it will touch positive 1 because of the nature of the graph. So when it is negative 1, the value corresponding would be pi, and positive 1, the value corresponding would be 0. And when x is equal to 0, cos inverse of 0 would be pi over 2. So we have to get this graph correct. Now if I'm just drawing this line just to indicate the point negative 1. So the function is not defined beyond this. The function is not defined beyond this positive 1. So only for negative 1 to 1 the function is defined. So that means x tending to, because we are expected to find the limit of cos inverse of x as x is approaching negative 1. So x tending to negative 1 from the left hand side is not required. Why is it not required? For the very fact the function is not defined on the left side of negative 1. So that is the reason. So this is the graph. Now let me just find out what happens to cos inverse of x as x approaches negative 1 from the right hand side. So that is what we are asked or we are required to obtain. So as we are moving here towards negative 1 from the right hand side, now the function is actually heading up. It's actually heading up, right? It's moving up and it's hitting this point. Now what is the value that is corresponding here? It's pi. So this value that we are seeing here is going to be pi. So how are we going to state it? As x tends to negative 1 from the right side, f of x tends to pi, and this implies limit x's, and you can simply state it as LE. So this is a beautiful question and I hope you understood this. Students, we move on to the next topic, which is called as Indeterminate Forms. Now the following are considered to be as indeterminate forms in limit problems. So let me give you those indeterminate forms. So 0 over 0, this is one form. Infinity over infinity, this is also an indeterminate form. 0 multiplied with infinity, this is an indeterminate form. You can also have infinity multiplied with 0, and then
infinity, negative infinity. This is also an indeterminate form. 0 raised to the power of 0. This is not equal to 1, but a lot of people will say it's equal to 1. That's incorrect. 0 raised to the power of 0 is indeterminate form. Infinity raised to the power of 0. This is also an indeterminate form. And 1 raised to the power of infinity. It is important to understand 1 raised to the power of infinity is not equal to 1. So these are the forms that we will be dealing with in this section. Students, we will start off by handling questions of 0 over 0 form and infinity over infinity form. Now there are 3 ways by which you can solve one of these forms. The first way is through factorization. The second technique is through rationalization. And the third one is called as Hopital Rule. Now we will take an illustration to have a better understanding. We are expected to find the limit of this function x raised to the power of 2 negative 5x positive 6 divided by x squared negative 4. So this is what is given. Now the first thing that we need to do is APL. Now APL stands for applying limits. So if you were to apply limits, what would you get? In place of x you have to substitute 2, and that's exactly what I'm doing. And this is equal to 2 squared negative 10 positive 6 divided by 4 negative 4. 4 with 6 would give me 10 negative 10 divided by 2 squared is 4. So 4 negative 4. So this is 0 over 0 form. You will have to explicitly state this. It is important that you are actually going to do what you are going to do on account of this 0 over 0 form. Now as I mentioned to you, we can easily factorize, or we can rationalize, or we can apply Hopital rule. Now I've got x squared negative 5x positive 6. So if I were to factorize this, 3 times 2 would have to give me 6, and 3 added with 2 should give me 5 with a negative sign. So this is obviously negative 3 negative 2. So that's exactly what I'm going to write. So I can write x squared negative 5x positive 6 as x negative 3 times x negative 2. So let me show you that. X into x gives me x squared. X into negative 2 would give me negative 2x, and negative 3 into x would give me negative 3x. Negative times 3 into negative 2 would give me 6. So this factorization is fine. So by factorization, I'm just going to state it. The numerator is returned as x negative 3 and x negative 2, and we shouldn't even, or I should say, we should not ignore the denominator. The denominator is written as x negative 2 times x positive 2. Why? Because if I were to have a squared negative b squared, I can rewrite this as a negative b times a positive b. That's what I'm doing here. So if I were to take this as 1, therefore I can rewrite 1 to be as x negative 3 times x negative 2 divided by x negative 2 times x positive 2 with the limit x tending to 2. So x negative 2 cancels off, giving me x tending to 2 of x negative 3 divided by x positive 2. Now applying limits, we get, maybe you can add those things. So what do you get? In place of x I substitute 2, and that is going to give me negative 1 divided by 4. So you can sum up the solution. So therefore limit x tending to 2 of x squared negative 5x positive 6 divided by x squared negative 4 is equal to negative 1 over 4. So this is the value. Now we can do the same thing by Hopital rule. So what is the Hopital rule?
So I'm going to show that to you. So we got limit extending to 2 of x squared negative 5x positive 6 divided by x squared negative 4. Now you will have to apply the limits to show, or in other words, before you could apply Hopital rule. So applying limits, we get, so what do you get? In place of x you substitute 2, and that is going to be giving you 0 over 0 form, which is indeterminate form, right? Now by Hopital rule, okay, we get, now what is the Hopital rule? It's simple. We differentiate the numerator, differential of the numerator exclusively, and we divide it by the differentiation of the denominator, and then we apply the limits. This is what is Hopital rule. So this is equal to, I differentiate the numerator. So what would you get when you differentiate the numerator? You get 2x negative 5. Differentiation of denominator, you get 2x. Now you apply the limits extending to 2. So you state it. So what do you get? 2 times of 2 negative 5 divided by 2 times of 2. What is this? 4 negative 1. 4 negative 5 will give you negative 1, and 2 times 2 is 4. So this is exactly what you've got. You got here negative 1 over 4, you got negative 1 over 4. So both the techniques are valid, and both the techniques are producing us the same result.
Students were expected to evaluate this question. Limit extending to 1 of x squared positive x times log x to the base e, negative log x to the base e, followed by a negative sign, and that is divided by x squared negative 1. So foremost, what we got to do is we have to apply the limits. So applying limits, we get, you got to write the statement. So this is going to be 1 squared negative 1 time, this is log x to the base e, so I prefer writing it as ln. So ln 1 negative ln 1 negative 1 divided by 1 negative 1. Now this is actually positive sign. Now positive 1 squared is 1 and negative 1, they both get cancelled. This is going to be ln 1 and negative ln 1, they get cancelled, giving me 0. 1 negative 1 is 0. So this is 0 by 0 form. You have to explicitly state this. Now what we are going to do is, first we are going to adopt the method of factorization to solve this. So what I want to do is I want to club x squared with negative 1, and then I will club x times ln x negative ln x together divided by x squared negative 1. X squared negative 1, I'm going to rewrite x squared negative 1 as x negative 1 times x positive 1 followed by x negative 1 times ln x divided by x squared negative 1. Now from here I'm going to take x negative 1 out, so that would give me x positive 1 followed by ln x divided by x squared negative 1. Now I'm going to rewrite the denominator x squared negative 1 as x negative 1 times x positive 1. Of course in the numerator I got x negative 1 times x positive 1 positive ln x. Now x negative 1 can be cancelled, giving me x positive 1 positive ln x divided by x positive 1. Now I can apply my limits now. So applying limits, in place of x I substitute 1. So this is ln 1 divided by 1 positive 1. Ln 1 is 0, 1 positive 1 is 2, and denominator I got 2. So 2 divided by 2 is 1. So therefore limit x tending to 1 of x squared positive x times ln x negative 1 divided by x squared minus 1 is equal to 1. So this is by factorization technique. Now I can do the same question, limit extending to 1 of x squared positive x times ln x negative 1 divided by x squared minus 1 by Hopital rule. So for that we will have to first apply the limits. On applying the limits we get 0 by 0 form. Remember, you can apply Hopital rule, either you get 0 by 0 form or you are getting infinity over infinity form. So only for these two forms Hopital rule will lead you to a solution. So having mentioned this, now
what I'm going to do is, this is nothing but I would differentiate the numerator and I would differentiate the denominator, and then I will tend x to 1. So differential of x squared is 2x. Differential of u, this is actually uv form. So let me write the formula. uv is u times v dash positive v times u dash. So this is the product rule. So it's going to be x times differential of ln x is 1 over x positive ln x times differential of x is going to be 1. So you can just simply write that as ln x, followed by negative differential of ln x is going to be 1 over x. Differential of 1 is 0, so no need to write. Differential of x squared is 2x. So x and x can be cancelled. So this is equal to 2 times x positive 1 positive ln x negative 1 over x divided by 2 times x. Now applying limits, what do we get? So this is equal to, in place of x I substitute 1, so this is going to be ln 1, this is going to be 1 over 1 is 1, this is going to be 2. Positive 1 negative 1 gets cancelled, ln 1 is 0, I get a 2 and I get a 2, 2 over 2 is 1. So I get the same answer. So clearly you can see we got 1 year and we got 1 year. So that completes the solution for this question, students. We'll move on to the next one. So we are expected to evaluate limit extending to 0 of root of 3 positive x negative root of x divided by x. So foremost, let us apply limits. This is going to give us root of 3 positive 0 negative root of, so let me just take this as 3. So this is going to be 0. Now this is going to be equal to root of 3 negative root of 3 divided by 0, which is equal to 0 over 0 form, right? So since it is 0 over 0 form, I'm going to apply the factorization for this particular question. So how am I going to, in fact I would be applying rationalization. So we would use the rationalization technique. So for that, let me write that down. Root of 3 positive x negative root of 3 divided by x. I'm going to multiply this by root of 3 positive x positive root of 3 divided by root of 3 positive x positive root of 3. Now this is going to give me root of 3 positive x raised to the power of 2 negative root of 3 raised to the power of 2 divided by x times of root of 3 positive x. In fact, there is a positive sign, so positive root of 3. Now this is going to be 3 positive x negative 3 divided by x times of root of 3 positive x positive root of 3. Negative 3 positive 3 gets cancelled. I got a x and a x can be cancelled. So this is equal to 1 over root of 3 positive x positive root of 3. Now applying limits, in place of x I substitute 0. So I get 1 over root of 3 positive root of 3 is equal to 1 over 2 times root 3. Now I can get rid of this root 3 by multiplying the numerator and the denominator by root 3. So that would give me 3 over 2 times 3, which is equal to 2 times 3 is 6. In fact, this is root 3. So I can rewrite this as root 3 divided by 6, right? And that is a good place for us to stop with regard to the solution. So let me draw the red line. We are going to be applying Hopital Rule. So before we could apply the Hopital Rule, we will have to apply the limits. So applying limits, we get, so what do we get? Root of, in place of x I substitute 0 followed by negative root of 3 divided by 0. This is going to be root of 3 negative root of 3 divided by 0, which is 0 over 0 form. So you will have to explicitly state this. Now next is by Hopital Rule. So what do we get? So actually we will have to differentiate. So this is going to be differentiation of the numerator. I'm going to write the numerator as 3 positive x raised to the power of 1 over 2 negative 3 raised to the power of 1 over 2 divided by the differentiation of the denominator, which is x, and then we will have to apply the limits, limit x tending to 0. Now this is going to be, differential of this is going to be 1 over 2 times 3 positive x raised to the power of 1 over 2 negative 1 times differentiation of 3 is 0, differentiation of x is 1, this differentiation is 0, divided by differentiation of x is 1. So if I were to rewrite this, this is going to be 3 positive x raised to the power of negative 1 over 2 times 1 over 2, which is equal to 1 over 2 times square root of 3 positive x. So this is what I've got. Now I will have to apply the limits. So applying limits, what do we get? This is equal to 1 over 2 times root of 3 positive 0, which is equal to 1 over 2 times root 3. This was the exact result we got. You can either stop here or you can rationalize it by multiplying the numerator and the denominator by root of 3. So you would get root 3 in the numerator. Root 3 times root 3 will give you 3. So it's going to be 2 times 3, which is nothing but root of 3 divided by 6. So this is a good place for us to stop for the application of Hopital Rule. So we'll move on to the next question. Students, we are given this question. F is defined from R to R such that f of 2 is given to be as 4 and f dash of 2 is given to be as 1. We are expected to find the value of limit x tending to 2. The numerator term is x squared times f of 2 negative 4 times f of x divided by x minus 2. So foremost what we have to do is, this is given. So let me just start off by writing the problem. Given that limit x tending to 2 of x squared times f of 2 negative 4 times f of x divided by x minus 2. So we are expected to evaluate this. Now to start off, we will apply the limits. When applying the limits, we get 2 squared, f of 2 is 4 followed by negative, and f of x is given, so we are substituting f of 2 again, and that is 4 here divided by 2 negative 2. 4 times 4 is 16, 4 times 4 is 16, 2 negative 2. So this is 0 by 0 form. So we have reached this form. So now I'm going to use Hopital Rule. By Hopital Rule we get, so what is the Hopital Rule? Differentiating the numerator and followed by differentiating the denominator, then I apply limit x tending to 2. So if I were to do that, differential of the numerator, it's UV formula. So I will be using d of UV is u times v dash positive v times u dash, the product rule. So x squared times differentiation of f of 2, that's 0, followed by f of 2 times differential of x squared, that's 2x, and then scalar 4 is a constant, you take that out, differentiation of f of x is f dash of x. This has to be divided by differentiation of x minus 2, that's going to be 1. So now I'm going to rewrite this as 2 times x f of 2 negative 4 times f dash of x divided by 1. So I don't have to place 1 there, but it's okay. So now I need to apply the limits. The limits are x tending to 2. So let me write that down here. Applying limits, we get, so what do we get? This is nothing but 2 of 2. F of 2 is given to be as 4. So 4 negative 4 times f dash of 2, right? F dash of 2 is given to be as 1 divided by 1, which is equal to 2 times 2 4 times 4 negative 4 is equal to 4 4s are 16, negative 4 is equal to 12. So this is the final solution, and it's a good place for us to draw the red line. So that completes the solution for this question, students. We'll move on to the next one. Students, we are given this question. F of x is equal to x raised to the power of 6 positive 2 times x raised to the power of 4 positive x raised to the power of 3 positive 2x positive 3 such that x is element of real number, and we are expected to find a natural number n for which this function equals 44. And what is this entire component? X raised to the power of n times f of 1 negative f of x divided by x minus 1 with limit extending to 1. So this is the function. This is the function we are looking forward, and we are expected to find for what value of n this function as limit x tending to 1 leads us to 44. So the objective is to find n. Okay, so let me just start off by writing what is given. Given the function x tending to 1 of, in fact, instead of saying given, I will say let us consider, I think that's a more appropriate word, limit x tending to 1 x raised to the power of n f of 1 negative f of x divided by x negative 1. Now as x tends to 1, so first we will apply the limits. So applying the limits we get, so what do we get? So this would mean in place of x I substitute 1, so it's going to be 1 raised to the power of n f of 1 negative f of 1 divided by x negative, in fact it's 1 negative 1, right? Now 1 raised to the power of n, that's going to be 1, so 1 times f of 1 is going to be f of 1 minus f of 1 divided by 1 negative 1. This is 0 by 0 form, so I will have to explicitly state that form. Now we are going to be applying Hopital rule. So by Hopital rule we get, so what do we get by Hopital rule? What is Hopital rule? It's nothing but differentiating the numerator divided by differentiating the denominator and then applying x tending to 1. So let's do that. So if I were to differentiate x power n, f of 1 is a constant, so you take that out, differentiate x power n, that's going to be n times x raised to the power of n negative 1 followed by differentiation of f of x, that's f dash of x, divided by differentiation of x, that's 1. So this is what we have got. So now the question comes is applying the limits. So applying the limits we get, so in place of x I substitute 1, so it's going to be f of 1 times n times 1 raised to the power of n minus 1 negative f dash of 1 divided by 1. We don't have to specify that, but just for sake of consistency I placed there 1. Now 1 raised to the power of n minus 1, that's going to be 1. So we got n times f of 1 minus f dash of 1. Now what is f of x? This is given, so let me write that down. F of x is equal to x raised to the power of 6 positive 2 times x raised to the power of 4 positive x raised to the power of 3 positive 2x positive 3. Now at x is equal to 1 we need to find f of 1. So what is this? This is 1 positive 2 positive 1 positive 2 positive 3. 2 added with 1 3 4 6 6 added with 3 will give me 9. Now I need to obtain f dash of 1. So for that I need to find out what is f dash of x. F dash of x is 6x power 5 positive 8x power 3 positive 3 times x squared positive 2. Now f dash of 1 is going to be 6, 8, 3 and 2. This is 14, 17 and 19. So this is going to be n times f of 1. F of 1 is 9 minus f dash of 1 is 19. So this is what we have got now. Now what is the functional value as x is tending to 1? The functional value as x is tending to 1 is given to be as 44. So if I were to name it as 1, I'm going to use the space here. So from 1 we get, so what do we get? N 19 times n, it's 9 times n. 9 times n, negative 19 is equal to 44, right? So I push this 19 to the other side. It means 44 added with 19. This is going to give me 3 and 63.
So 9n is equal to 63. So n is equal to 63 by 9. So 9 divided 63 7 times. So therefore the value of n is 7. So this is equal to this when n is equal to 7. So that completes the solution for this question, students. Students, we are given the question, we are expected to find the value of n given that limit extending to 1 of x positive x squared positive x to the power of 3 etc. x raised to the power of n negative n divided by x negative 1 is given to be as 820. Now applying limits, we see that 0 by 0 form is obtained because of this fact that we got x raised to the power of n and x is tending to 1. Hence, applying Hopital Rule, we get, so what do you get when you apply Hopital Rule? It is nothing but limit extending to 1, differentiating the numerator divided by differentiating the denominator, which is equal to limit x tending to 1 of differential of x is 1, differential of x squared is 2x, differential of x power 3 is 3 times x squared plus etc. Differential of x power n is n times x to the power of n negative 1, differential of this n is 0, divided by differentiation of x negative 1 will give me 1. But this functional value is actually given to be as 820. Right, so before we could get that, let us write that down, 820. Now applying the limits, we get, so what do we get when we apply the limits? We get 1 positive, 2 positive, 3 plus etc. up to n is equal to 820. Now what is this? This is nothing but n into n positive 1 divided by 2 is equal to 820. Right? Now from here I can rewrite this to be as n into n positive 1 is equal to 2 times 820. So this is going to be n squared positive n negative 8. I need to multiply this and bring it over onto this end. So that would give me 0, 4, 16 is equal to 0. So this is a quadratic equation we have to solve it. So if we were to use quadratic method, this n is going to be equal to negative b, in this case 1 plus or minus root of negative, so it's going to be root of b squared is 1 squared, negative 4 times a is 1 and c is negative 1640 divided by 2 times of 1. Now if you were to multiply this, is going to be 0, 4 4s are 16, 1, 6 4s are 24, 25, 2 4s are 4, 5, 6, plus a 1 and a root and negative 1 plus or minus divided by 2. So this is nothing but negative 1 plus or minus root of 6561 divided by 2. So this is my n. So what is square root of 6561? This is nothing but 81. So let me use this space here. So n is equal to negative 1 plus or minus 81 divided by 2. So I get two values. N is equal to negative 1 positive 81 divided by 2, which is nothing but 80 divided by 2. So n is equal to 40 in one case, or the other case n is equal to negative 1 negative 81 divided by 2. So in this case it is 82 divided by 2 and the value of n is 41, negative 41. So we have got n is equal to 40 and negative 41, and we will have to take the positive value. So we can conclude therefore the value of n is equal to 40. Now this is done using quadratic. If you are
lucky enough, then you don't have to use quadratic. So what do I mean by lucky enough? Now actually we have got n into n positive 1 is equal to 1640, right? I can rewrite 1640 as 40 times 41, right? And on the left side I get n into n positive 1. So clearly from here I can write n to be equal to 40. So it all depends on your ability to defragment the quantity given, and if it is easy for you, then you can apply this. If not, you can always use the standard quadratic method, which will never fail you. So according to that, I have also got the value of n to be equal to 40. So this is the solution to this question, and we will move on to the next question, students. Students were expected to evaluate this question. Limit x tending to 2 of 3 raised to the power of x, positive 3 raised to the power of 3 negative x, negative 12 divided by 3 raised to the power of negative x over 2, followed by a negative sign and 3 raised to the power of 1 negative x. Foremost, we will apply the limits. Now when we apply the limits, we are checking for 0 by 0 form. So x is tending to 2, so this is 3 squared positive 3 raised to the power of 3 negative 2 negative 12 divided by 3 raised to the power of negative 2 over 2 negative 3 raised to the power of 1 negative 2. So this is going to be 3 squared is 9, positive this is 3 negative 12 divided by, this is going to be 3 power minus 1, and followed by 3 raised to the power of 1 negative 2 is 3 power minus 1. So clearly 12 negative 12 is 0, 3 raised to the power of negative 1 followed by a negative sign, and 3 raised to the power of negative 1 will be 0. So we have got the 0 by 0 form. Okay, so now we will have to evaluate this. Now we can't be applying Hopital rule because of the fact that we have a quantity that is raised to the power of x. So we will have to approach a different technique. So foremost, what I'm going to do is I'm going to rewrite limit x tending to 2 of this quantity as 3 raised to the power of x, followed by positive 3 raised to the power of 3 times 3 raised to the power of negative x, negative 12, divided by, this is going to be 1 over 3 raised to the power of x over 2, followed by a negative sign and 3 raised to the power of 1 times 3 raised to the power of negative x. This is rewritten as 3 raised to the power of x positive 3 raised to the power of 3 divided by 3 raised to the power of x, negative 12, divided by 1 over 3 raised to the power of x over 2, negative 3 over 3 raised to the power of x. So I've got a quantity like this. Now what I wish to do is I would like to make a substitution. Okay, of course you got your limit x tending to 2. Now what is the substitution I'm going to make? I'm going to state here, let 3 raised to the power of x over 2 be equal to some t, squaring both sides. This is going to be 3 raised to the power of x over 2 raised to the power of 2 is equal to t squared. So this would mean 3 raised to the power of x is equal to t squared. So this is a substitution. That's because 2 and 2 can be cancelled, so you are ultimately left with 3 raised to the power of x is equal to t squared. So we can make the substitution to this function. So this is equal to limit, since we are going to change it to t, I'm not going to place x tending to 2, so let it be as it is. I will come back to this limit within a minute. Now 3 raised to the power of x, this is going to be t squared, positive 3 cubed is 27, 3 raised to the power of x is t squared, followed by negative 12, that's for the numerator, divided by 1 over 3 raised to the power of x over 2 is t, followed by 3 over 3 raised to the power of x is t squared. So we got this. Now we have taken 3 raised to the power of x over 2 to be equal to t. So as x tends to 2, 3 raised to the power of x over 2 is equal to 3 raised to the power of 2 over 2, which is equal to 3. So this would mean when x is tending to 2, Since I've taken t to be as 3 raised to the power x over 2, this would mean my t would be tending to 3. So in this case, this is going to be t tending to 3. So if I were to simplify this, this is equal to limit t tending to 3. I take the LCM as t squared, so this is t power 4 positive 27 negative 12 times t squared divided by t squared. The whole is divided by, if I were to take t squared as the LCM, I would get t negative 3 divided by t squared. T squared can be cancelled. I can rewrite this as limit t tending to 3 of t raised to the power of 4 negative 12 times t squared followed by 27 divided by t negative 3. Now this is actually a quadratic in disguise. Now why do I say a quadratic in disguise? Now if I were to actually rewrite this, I can simply say t squared is equal to some p, and then this is going to be p squared negative 12 times p positive 27. Okay, so if I were to factorize, I've got 12 here and I need to get a 27. So let me write that down. So it has to be a negative 12 and I need to get a 27. So if I were to place here 9 and 3, 9 times 3 is 27. Right, now if I add 9 and 3 I get 12, but I need to get a negative sign. So if I can place it like this. So if I were to rewrite this, I can rewrite this as p negative 9 times p negative 3. So this is going to be p squared, this is going to be negative 3p, this is going to be negative 9p, and this is going to be positive 27. Fair enough, right? So I'm getting back p squared negative 12p positive 27. That's fair enough. So I can actually rewrite this as with the original t tending to 3. I did all this just for your understanding, so I don't have to make any substitution as t squared is equal to p. I can directly factorize it as t squared negative 9 times t squared negative 3 divided by t negative 3. So we've got limit t tending to 3 of t squared negative 9 times t squared negative 3 divided by t negative 3. Now I can rewrite t squared negative 9 as t negative 3 times t positive 3 followed by t squared negative 3 divided by t negative 3. Of course the limit is t tending to 3. Now t negative 3 and t negative 3 can be cancelled, giving me t positive 3 times t squared negative 3. Now if I were to apply the limits, this is going to be 3 positive 3 times 3 squared negative 3, which is equal to 3 positive 3 would give me 6, and this is going to be 9 negative 3, this is going to be 6, 9 negative 3 is 6, 6 times 6 is 36. So this is the solution. Now if you were to see the question is a little bit challenging. This is a question that was given to us, but the solution is too simple. So that is because we have removed the challenges by effective substitution technique. So that is the underlining point that we have to take into focus. Students were expected to evaluate limit x tending to infinity of 2x positive 3 divided by 5x negative 4. Now applying limits, we get this is going to be 2 times of infinity positive 3 divided by 5 times of infinity negative 4. So this is going to be infinity over infinity form, and which is actually an indeterminate form. Now there are two ways to solve this. One, we can directly apply Hopital Rule, or we can follow this following pattern. Now what I'm going to do, I'm going to retain limit x tending to infinity as it is, and I will take a x out. If I take x out, I will get 2 positive 3 over x divided by, I'm going to take a x out, this is going to be 5 negative 4 over x. X and x can be cancelled. Now as x tends to infinity, 1 over x will tend to 0. So this would mean this will be 0, this will be 0, and we are left with 2 over 5. So this will be the solution. Now this is method 1. Now method 2, I will be just applying Hopital rule. By Hopital rule, we get, so what do we get by Hopital rule? That is nothing but limit x tending to infinity of differentiation of the numerator divided by the differentiation of the denominator. This is equal to limit x tending to infinity of, when you differentiate the numerator you get 2, when you differentiate the denominator you get 5, and there is nothing to apply here, there is no x term. So this is equal to 2 over 5, and still you get the same solution. So let's do another question. We got evaluate limit x tending to infinity of 2 times x squared negative x positive 1 divided by 3 times x squared positive 5x negative 6. Now applying limits, what do we get? Clearly we get infinity over infinity form. Now I will be using method 1, which I've just shown you here. So according to that method, this is going to be limit x tending to infinity of, I take x squared out, so this is going to be 2 negative 1 over x positive 1 over x squared divided by, I take x squared out, this will be 3 positive 5 over x negative 6 over x squared. So x squared can be cancelled. Now as x tends to infinity, 1 over x will tend to 0, and 1 over x squared will also tend to 0. So this will be 0, this will be 0, this will be 0, this will be 0. You are left with 2 over 3, which will be the solution. Now applying Hopital rule, let's do the method 2. I am applying Hopital rule. Now why am I applying Hopital rule? Because of infinity over infinity form. So what is the Hopital rule states? Limit x tending to infinity, differentiating the numerator divided by differentiating the denominator. This is equal to limit x tending to infinity of, I differentiate the numerator, I get 4 times x negative 1 divided by, differentiate the denominator, I get 6 times x positive 5. Now if I were to apply the limits, this is going to be infinity. Alright, now let me state that applying limits, what do we get? We get infinity over infinity form. So once you get infinity over infinity form, again we can apply Hopital rule. We apply Hopital rule again, right? So that would mean I differentiate 4x, which is 4, I differentiate 6x, which is 6, and the limit has to be placed here. Now there is nothing here to apply here, there isn't any x term, so this stays as it is. Maybe I can reduce this, 2 divides 4, 2 times 2 divides 6 3 times, so the answer is 2 over 3, which is exactly what we have got. So we got 2 over 3 here, we got 2 over 3 here. So that is the solution for this question, students. We'll move on to the next one. Students, now we are going to be looking into questions which are leading us to infinity, negative infinity form and 0 times infinity form. So these are two different forms. Now whenever you encounter either negative, I should say infinity, negative infinity form or 0 times infinity form, what you have to do is you will have to convert them into either 0 over 0 form or infinity over infinity form. That is the secret to solving questions of this nature. Solving infinity, negative infinity form or 0 times infinity form. So let us do a question to obtain a better understanding. Now we are expected to evaluate limit x tending to infinity of square root of 25x squared negative 3x negative 5x. Now foremost, let us apply the limits. So by applying limits we get, so what do we get?
this is going to be square root of 25 times infinity squared, negative 3 times infinity followed by 5 times infinity. So what is this? This is infinity negative infinity form. So now our duty is to convert this infinity negative infinity form to either 0 over 0 form or infinity over infinity form. Limit x tending to infinity of square root of 25 x squared negative 3x negative 5x. So this is going to be rewritten as, now I'm not going to touch the limit as of now, so let me just make the substitution. So this is going to be 25, x is 1 over t, so this is going to be 25 over t squared followed by negative 3 over t and then 5 over t. So this is what we have got. Now the limits, if x is tending to infinity, now let me just show you here, as x tends to infinity, what would t will tend to? T is actually, let me just write it here, t is 1 over x. Now x is tending to infinity, so this would imply t will tend to 0. So have that in mind. So I'm going to write that down here, t is tending to 0. Now I will have to simplify this part. So this is a limit t tending to 0 of, I'm going to take the LCM as t squared. This is going to be 25 negative 3 times t followed by negative 5 over t. So this is what we have got. Now clearly I can actually take the root for this. So if I were to take the root for this, this is going to be limit t tending to 0 of root of 25 negative 3t divided by t negative 5 over t. Now this can be further rewritten as limit t tending to 0 of root of 25 negative 3t minus 5 divided by t. Apply limits. So applying limits. So what do we get when we apply the limit? So this is going to be root of 25 minus 0 followed by negative 5 divided by 0. Now this is going to be root of 25 minus 5 divided by 0. Root of 25 is 5, negative 5 divided by 0. This is 0 by 0 form. So actually what we have done here is we have actually converted infinity negative infinity to 0 over 0 form. So that is what we have done. So either you can convert it into 0 over 0 form or infinity over infinity form. So having done that, now we will have to rationalize it. So we've got, I'm going to use the space here. So we have got limit t tending to 0 of root of 25 negative 3t negative 5 divided by t. What I wish to do, I will be multiplying by root of 25 negative 3t positive 5 divided by root of 25 negative 3t positive 5. So multiply and divide. So this is going to give me limit t tending to 0 of 25 negative 3t negative 5 squared divided by t times square root of 25 negative 3t positive 5. 25 and negative 25 gets cancelled, giving me negative 3t divided by t times of square root of 25 negative 3t positive 5. Of course you got the limit t tending to 0. Now t and t can be cancelled. Now if I were to apply the limits, this is 0, this is root of 25, that is 5. So let me state that applying limits, I would be getting negative 3 divided by 5, this is 0 plus 5. 5 positive 5 would give me 10. So this is the solution to the question, and it's a good point for us to draw the line. Thank you students, we'll move on to the next question.
Welcome students, we've been given this question, limit x tending to infinity of square root of x squared negative x positive 1 negative a times x is equal to b. Then we are expected to find the ordered pair a comma b. Now foremost, if we were to apply the limits, x is tending to infinity and that is going to be root of infinity followed by infinity times a, which is going to be infinity, which is subsequently going to be infinity negative infinity form. Now once you get this infinity negative infinity form, it is always advisable to make the following substitution: x to be equal to 1 over t. So we take x to be 1 over t, and if I were to take this as 1, therefore 1 can be rewritten as, in place of x is going to be 1 over t, since it is x squared, so it's going to be 1 over t squared negative 1 over t positive 1 negative a times 1 over t. So that's the way I have placed 1 over t. Now as x tends to infinity, in this case t will be tending to 0. So this is going to be limit t tending to 0. Now if I were to simplify this, I would have to take square root of, I'm taking t squared to be the LCM, so I will get 1 negative t positive t squared negative a over t, limit t tending to 0. Now this can be further rewritten as square root of 1 negative t positive t squared negative a. Now root of t squared is going to be t, and I got a t here, and this is going to be limit t tending to 0. Now if I were to take t to be as the LCM, this is going to lead me to 1 negative t positive t squared negative a, and I get limit t tending to 0. Now applying limits, we get, so what do you get when you apply limits? This is going to be root of 1 negative 0 positive 0 negative a divided by 0, which is equal to root of 1 negative a divided by 0. Now it is imperative to understand that the question says limit x tending to infinity of root of x squared negative x positive 1 negative a times x is equal to b. So that means the limit is existing. Now for the limit to exist, the function should lead us to a 0 over 0 form. Only if the function leads to 0 by 0 form, the function will have a limit. So have that in mind. So let me reiterate one more time. For the function to have this limit b, it is given the function should lead to 0 over 0 form. But apparently in this case we have got root of 1 negative a divided by 0. So this means the value of a should be equal to 1. Now why do I say that? Because since root of 1 is 1 and a is equal to 1, and that would lead me to 0 by 0 form. Okay, so this is a very important point that you will have to know. So what we are going to do is we are going to take the value of a to be equal to 1. So if I were to take this as 2, let me use this space here. Since a is equal to 1, therefore 2 can be rewritten as square root of 1 negative t positive t squared negative 1 divided by t. This is limit t tending to 0. Now if I were to multiply by, in fact I'm going to be rationalizing, so by rationalization we get, so what do we get? We got root of 1 negative t positive t squared negative 1. We are going to be multiplying by root of 1 negative t positive t squared positive 1 divided by root of 1 negative t positive t squared positive 1. There's already a t here. Of course, this entire thing has got a limit t tending to 0. Now this is going to give me 1 negative t positive t squared negative 1 divided by t times square root of 1 negative t positive t squared and positive 1. Okay, so this is going to be limit t tending to 0. Now positive 1 negative 1 gets cancelled. I can take a t out. If I take a t out, probably I'll take a negative t out. So this is going to give me 1 followed by negative t. Right, t times 1 will give me t with a negative sign, and negative t times negative t will give me positive t squared divided by, I get a t times square root of 1 negative t positive t squared positive 1. This is limit t tending to 0, right? So t and t gets cancelled. Now since applying limits, okay, let me just apply limits. Now applying limits, what do we get? This is going to be negative 1 negative 0 divided by root of 1 negative 0 positive 1, which is equal to negative 1 divided by, this is 0, this is 0, root of 1 is 1, positive 1 is going to be negative 1 over 2. So what is this? This is my value for b, because if you were to look at the problem, it says the limit for the function is equal to b. So this implies the required ordered pair a comma b is 1 comma negative 1 over 2. So this is a good place to draw the red line. We'll move on to the next question, students. So this is a beautiful question. Students, we are given this question: if limit x tending to 0 of square root of ax positive b negative 2 divided by x is equal to 1, we expect to find a and b. Now point number 1, it is given that the limit of the function is equal to 1, so that is important, and using that important information we are going to be obtaining the value of a and b. So first step is applying limits. When we apply limits, x is tending to 0, so this is going to be root of a of 0 positive b negative 2 divided by x is equal to 0. So this is equal to root of a times 0 is 0 positive b negative 2 divided by 0. Now since the function has a limit, this should be equal to 0 over 0 form. Now when would this be equal to 0 by 0 form? Because this is nothing but root of b negative 2 divided by 0, right? So for this quantity to be 0 by 0 form, the value of b should be equal to 4. So we have already obtained the value for b. Now when b is equal to 4, what happens to this given system? So if I were to take this as 1, I'm going to write this: when b is equal to 4, therefore I can rewrite 1 to be as limit x tending to 0 root of a times x positive 4 negative 2 divided by x. Of course there is equal to 1. This is already given. Now let me rationalize this. By rationalization we get So what do we get by rationalization? This is going to be root of ax positive b negative 2 multiplied with root of ax positive b positive 2 divided by x times root of ax positive b positive 2. This is equal to 1. So this can be rewritten as ax positive b, right, negative 4 divided by x times root of ax positive b positive 2. Now since b is equal to 4, clearly these two can be cancelled. So if these two can be cancelled, I am left with ax divided by x, which can be cancelled. Of course I get equal to 1, so this is going to be a divided by root of ax. B is 4 positive 2 is equal to 1. Now the limit for this is tending towards 0, right? So the limit is tending towards 0. In this case also the limit x tending to 0, but I have not applied the limits. Now if I were to apply the limits, now I am applying the limits. Applying limits, what happens? This is going to be 0, so I get a divided by, this is 0, so this is root of 4 positive 2 is equal to 1. Let me use the space here. So this is a divided by root of 4 is 2 positive 2 is equal to 1. So a divided by 4 is equal to 1. So therefore a is equal to 4, right? So we have got the value for a and we have got the value for b. In fact, I should have placed the box here. So that completes the solution to this question, students. We will move on to the next question. Students, we are given this question: if limit x tending to 1 of x squared negative ax positive b divided by x negative 1 is equal to 5, then we are expected to find a positive b. Now foremost we will apply the limits. Now applying limits, x is tending to 1, so there is going to be 1 negative a positive b divided by 1 negative 1, that's going to be equal to 0. Now it's given that this function has a limit. Now for the function to have a limit, this should be 0 by 0 form. So for this to be 0 by 0 form, it is necessary for 1 negative a positive b to be equal to 0. So we have got the first equation. Probably I can state it if you want. Since it is given that the function has a limit, hence it is necessary for 1 negative a positive b divided by 0 to be of the form 0 over 0, and that is only possible if 1 negative a positive b is equal to 0. So this is just for your understanding. Now having obtained this equation, so let us move on. So since it is 0 by 0 form, we will apply Hopital Rule. Now what is Hopital Rule? Differentiation of the numerator divided by the differentiation of the denominator with the limit x tending to 1. So which is equal to limit x tending to 1, differentiation of the numerator is 2 times x negative a divided by differentiation of the denominator is 1. So this is what we have got. Now the limit is given to be equal to 5. So what I'm going to do is I'm going to apply the limits. So applying limits, we get, so what do we get? This is 2 times of 1 negative a divided by 1 is equal to 5. 2 negative a is equal to 5. So if I were to move a to the other side, bring 5 to this side, it's 2 negative 5 is equal to a. Therefore a is equal to negative 3. Now a is equal to negative 3, hence 1 can be rewritten. In fact, I want to take it as 2. I don't want to have it as 1, because usually the given problem is taken to be as 1. So the hence 2 can be rewritten as 1 negative of negative 3 positive b is equal to 0. Therefore b is equal to negative 4. So in this question we are expected to find a positive b. So therefore let me write that down. A positive b is equal to, the value of a is negative 3, the value of b is negative 4, hence a positive b is negative 7. So this is a good place to draw the red line. Since we are given this question, limit extending to 0 of a negative square root of a squared negative x squared divided by 4, the entire thing is divided by x to the power of 4, is given to have a limit. And it also states that a is greater than 0. And we expected to find the value of a. Now to handle this question, we would be requiring binomial expansion. Okay, so when I say binomial expansion, I'm talking about the famous binomial series expansion. Two important series forms we will be requiring to answer questions of this nature. Now the first one is 1 positive x raised to the power of n. I know you all know the binomial expansion. I'm not going to use the entire expansion. I'm only going to take finite terms in the series. It's always acceptable whenever we are dealing with series. So in this case, 1 positive x raised to the power of n, I'm taking it as 1 positive n times x. Now why am I taking only first two terms? Because depending upon the limit, if x is going to be tending towards 0, the other terms are going to become very, very small. So there is no point in using them. So that is the rationale that is being used to take only finite terms. Now in this case I'm taking two terms. Now there is also another expansion, 1 positive x raised to the power of n. In this case we will take three terms, say 1 positive n times x, positive n into n negative 1 divided by 2 times x raised to the power of 2. So these two forms would be predominantly used. As I mentioned to you, we are not taking other terms owing to the fact that x is tending towards 0. As x approaches 0, the other terms would become very, very small. So there is no point in taking them on. So having mentioned this, I'm going to be solving this question. So foremost, as always, we will have to apply the limits. So when I apply the limits, I'm getting 0 by 0 form. So you can clearly see this is 0, this is a squared, root of a squared is a negative a is 0, this is going to be 0, this is going to be 0. So 0 by 0 form. So that is also a rationale for us to conclude, because definitely it has to lead to 0 by 0 form, because it says that the function has a limit. So now that we have got 0 by 0 form, we have the liberty of choosing the method that we want to apply onto this function so that we can extract the limit. So we would be using binomial expansion. So for that, to make this applicable or to facilitate the application of binomial expansion, I need to do some initial manipulation. So what am I going to do? I'm going to just start off by stating that limit extending to 0, and I'm going to rewrite a squared negative x squared as a squared negative x squared raised to the power of 1 over 2, followed by x raised to the power of 2 divided by 4. The entire quantity is divided by x to the power of 4. I'm not going to be much bothered about the limit that is given. First, let me simplify the terms that are present here. Now, as you can clearly see, the binomial expansion starts with the term 1. So I need to get the term 1 there. So this is rewritten as a negative. If I were to take a squared out, this is going to be 1 negative x squared divided by a squared. This is raised to the power of 1 over 2. This also has to be raised to the power of 1 over 2, followed by negative x to the power of 4 divided by 4. Negative x to the power of 2 divided by 4. The entire term is divided by x to the power of 4, and we got the limit extending to 0. So this is what we have got. Now clearly this can be rewritten as limit extending to 0 of a negative. Now a squared raised to the power of 1 over 2, that would give me a, followed by 1 negative x to the power of 2 divided by a squared. This is raised to the power of 1 over 2, negative x to the power of 2 divided by 4. This entire term is divided by x to the power of 4. Okay, now having got this, I'm going to apply binomial expansion to this particular term. So for that, let me just use this space here. So I'm going to consider 1 negative x over a raised to the power of 2. This is raised to the power of 1 over 2. Now we know that one positive, I'm going to use this expansion, in fact I will be using this, 1 positive x raised to the power of n is equal to 1 positive n times x positive n into n negative 1 divided by 2 times x to the power of 2. So in this case, instead of plus I got a minus, so that means the signs would be alternating. That is the first observation you will have to take into consideration. The second one is, in place of n I got 1 over 2, and in place of x I've got x over a raised to the power of 2. So that is the second observation. So having stated that, let me expand this. So this is going to be equal to 1. The first term would have an alternating sign, so that means that term is going to have a negative sign, and my n is 1 over 2, so place that 1 over 2 there, let it be in parenthesis, times x. My x is x over a raised to the power of 2, right? So let me write it as x squared and a squared. So the best way to do is to place them as a single term. In fact, instead of actually placing a parenthesis, you could have taken the 2 inside, but I don't want to make some alteration now. So let me continue. So followed by, I already taken a negative sign, so this is going to be positive. Now in place of n, I need to use 1 over 2. So this is going to be 1 over 2 times 1 over 2 negative 1. Of course there is a 2 there. X squared is going to be x squared a squared raised to the power of 2. Okay, so I'm going to stop with this term. Now I can rewrite this as 1 negative 1 over 2 times x squared divided by a squared positive 1 over 2 times 1 over 2 negative 1, that's going to be negative 1 over 2. Already there's a 2 there, so that can be brought over here, and then you got x to the power of 4 divided by a to the power of 4. So this is what we have got. Now is there any simplification that is possible? Well, let me just rewrite this again. So it's going to be 1 negative x squared a squared times 2, and this is 2 and 2 and 2. So you got a lot of 2's there. So that's going to be negative 1 over 2 times 2 is 4, 4 times 2 is 8, and this is going to be x to the power of 4 divided by a to the power of 4. So this is the expansion. This is this term that we would use instead of this term. So let me place it there. So if I were to take this as 2, therefore my 2 can be rewritten as limit x tending to 0 of a negative a times 1 negative x squared over 2 times a squared negative 1 over 8 x to the power of 4 a to the power of 4, that is for this term, followed by negative, there is x squared over 4. Okay, so divided by x to the power of 4. So now you need to make some further simplification. So this is equal to limit x tending to 0 of a negative a. Now this a is coming in, so it's going to be positive x squared over a and a squared, they get cancelled, leaving me 1a, followed by negative negative positive x to the power of 4, 8 a to the power of 4 with a there, that's going to be a to the power of 3, followed by negative x to the power of 2, that has to be divided by 4. So this is what we got. Positive a, negative a gets cancelled. So now I got x squared over 2a and x squared over 4. So we can club these two things together. Of course there is a x to the power of 4 term there, so let me just place that x to the power of 4 term there. Now if I were to club these two things, I can take x squared out and I can rewrite this as 1 over 2a negative 1 over 4 positive x to the power of 4 divided by 8 times a to the power of 3 divided by x to the power of 4. This entire thing will have a limit x tending to 0. Okay, now let me give you the solution here. Now I got x to the power of 4. Now I'm going to use this part for your understanding. Now by algebraic law, if I got a positive b over c, I can rewrite it as a over c positive b over c. Okay, so I'm going to write this as x to the power of 2 times 1 over 2a negative 1 over 4 divided by x to the power of 4 positive x to the power of 4 divided by 8a to the power of 3. Now x to the power of 4 I can actually write it over here, x to the power of 4. Okay, now this is limit x is tending to 0. Okay, let me place that. Now clearly an x and x squared and x can be cancelled, giving me 1 over 2a negative 1 over 4 times 1 over x to the power of 2. You have a limit x tending to 0, and this is followed by x power 4 can be cancelled, giving me 1 over 8 times a raised to the power of 3. Okay, now please follow me. As x tending to 0, 1 over x will tend to infinity. Now if 1 over x tends to infinity, this is infinity plus something, which means I am getting an infinity. But the question says the function has a limit L. So in other words, the function is already set to have a limit L, and we are now getting the limiting value for the function to be as infinity, which is actually a contradiction. So to avoid that contradiction, what should we do? We have to make sure that this term is 0. We have to make sure this term vanishes. So when would this term vanish? This term will only vanish when a is equal to 2. So if a is equal to 2, this is going to be 1 over 4 minus 1 over 4. This will become 0. This entire term will, in fact, this entire term will generate 1 over 8 times a raised to the power of 3. So it wouldn't be infinity. So I hope you are able to catch what I'm trying to say. So I'm going to state that this is for your explanation. This part which I've done is for explanation. You don't have to include that in the solution. So I'm going to write it here. Since given the function, okay, as the limit L, this implies x squared term should vanish. This means a should be equal to 2, right? They should perish. So for that to happen, a should be equal to 2. Hence, this in turn would imply limit x tending to 0 of x squared of 1 over 2a negative 1 over 4 positive x to the power of 4 divided by 8 times 8 to the power of 3 divided by x to the power of 4. This is giving us 1 over 8 times a to the power of 3. Now a is equal to 2. So this means 8 times 2 raised to the power of 3. 2 raised to the power of 3 is 8. 8 times 8 is 64. So the value is 64. So therefore L is equal to 64, which is a good place for us to stop. Thank you, students. I hope you understood this entire question.
Welcome, students. In this class we will understand the squeeze theorem. The squeeze theorem is also called as the sandwich theorem. Now the explanation of this theorem is as follows. Imagine you have a function, say f of x, and you got another function, say h of x, and between f of x and h of x you got a third function, say g of x. Now it is given that limit x tending to some point a, f of x has a limit L, and also for the same x tending towards a, h of x has a limit L. Now if these two conditions are existing, in other words f of x as x tending to a has a limit L and h of x as x tending to a has a limit L, then by squeeze theorem limit x tending to a of g of x will also be equal to L, because of the fact that g of x lies between f of x and h of x. Now if you were to visualize this could be visualized in the following fashion.
So this is the point A. X is moving towards this point A. So we got f of x and h of x. As x tending to A, f of x as a limit L, and as x tending to A, h of x as a limit L. Now g of x is defined between f of x and h of x. Now since g of x is defined between f of x and h of x, and as x tending to A, f of x has a limit L, and h of x as x tending to A has a limit L. This implies that g of x as x tending to A will also have a limit L. So this is the pictorial representation of squeeze theorem, or otherwise called as sandwich theorem. Now let me illustrate it with the simple example. I've got a function g of x defined between 4 times root of x and 3 times x squared negative 4x positive 5. Now graphically, if I were to represent this, let me just have it in this fashion. X-axis, y-axis, 0.0. 4 times root of x. Let me just assume that 4 times root of x looks like this. And 3x squared negative 4x positive 5. And x is equal to 0 if this point is 5. Imagine the graph is moving like this. So this is y is equal to 3x squared negative 4x positive 5. Right, so there is a point of contact, and let me just take this point as 1. Now at x is equal to 1, there is a common intersection for both these curves, and that point is going to be 4. Now because of the fact that if I were to substitute x is equal to 1, I get y is equal to 4, so fair enough. X is equal to 1, I get y is equal to 4. So that is the intersection which I am showing. Now given that g of x lies between 4 times root of x and 3x squared negative 4x positive 5, let us assume that our g of x flows between these two curves. Now because of the given fact that g of x lies between 4 times root of x and 3x squared negative 4x positive 5, if there is a requirement for us to find the limit value of g of x as x tends to 1, then that value, without an element of hesitation, we can write that to be equal to 4. Why? By squeeze theorem, or you can say sandwich theorem. Now we will move on to do other illustrations to get a better understanding. Now we got a question here. Given that f of x lies between 4x negative 9 and x squared negative 4x positive 7 for every x greater than or equal to 0, we expected to find the limit of f of x as x tends to 4. Now clearly the function given lies between two other functions. So first what I will do is I will first find out limit x tending to 4 of 4x negative 9. So maybe I can consider. Now applying limits, we get, so what happens when you apply a limit? This is 4 times of 4 negative 9, 16 negative 9, which is equal to 7. Also consider limit x tending to 4 of x squared negative 4x positive 7. Now applying limits, we get, what do we get? In place of x I substitute 4, that's 4 squared negative of 4 times 4 positive 7. This is 16 negative 16 positive 7, and you get 7. So you get a 7 as a limit here, you get 7 as a limit here. By squeeze theorem, since f of x lies between 4x negative 9 and x squared negative 4x positive 7 for every x greater than or equal to 0, this implies limit x tending to 4 of f of x will be equal to 7. So that is the end of solution for this question. So we move on to the next one. So this is the next question, students. Given that g of x lies between 2x and x to the power of 4 negative x squared positive 2 for every x, and we are expected to find the limit x tending to 1 of g of x. Foremost, what we are going to do is we are going to consider limit x tending to 1 of 2x, which is equal to, now I'm going to apply the limits. Applying limits, we get, So this is going to be 2 of 1 is equal to 2. Now consider limit extending to 1 of x to the power of 4 negative x squared positive 2. So applying limits, we get 1 raised to the power of 4 negative 1 raised to the power of 2 positive 2. So this is 1 negative 1 positive 2 is equal to 2. So clearly we get 2 to be the limit in both the cases. So hence by squeeze theorem, therefore limit extending to 1 of g of x will be equal to 2. So this is the solution for this question.